Good evening, class. We are back again. This week I sent y'all some homework problems based on what we've been working off of. So, as always, I will be glad to work with all of y'all to help kind of give you an idea of what to expect out of these questions. So, with all that being said, let's get right into things. Let's get rolling. All right. First, for the first question, you're given a sentence describing a situation. Your goal with that is to create a graph based off of that. It's nothing too complex, so it's not like I'm asking you for numbers or anything. So all I want to know is, like, what type of graph would you create based off of that? So, for example, the one about the car. Okay, so first of all, think about it. Here's an example of a graph that MATLAB provides. Now, which one makes sense kind of as your gallons of gas, and which one kind of represents something else? Now, for the gallons of gas, well, look at it right here. Right here. See how it goes down and goes up on the y-axis? That best represents a gas tank. Likewise, it kind of stays still and then while it fills up and then goes down. So based off of that, we can assume that the x-axis represents the distance you're driving because of this part of the y-axis that does not move. When y moves, the x does not. With that logic in mind, you just pretty much apply it to the other three parts of the question. For example, going to 1b. The floors, well, you move up one floor at a time, and then you stop to let people on. Go up, let people on or off. Up, on or off. Process continues. So, as a result, Y is your floors traversed, and X is your time you're staying still. Now for, once again, part C. The bow, the ball, the height. Boing, 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 boing. See how it kind of just goes? It just continues on. And if you can't think of anything else, just use time in seconds. It's kind of the generic thing to use when you can't think of anything else. And finally, 1D. This one is a little tricky because it can throw you off because our graph here, it never touches y equals 0, which means there's never a time when there's no shadows, and that's true. At the bright of day, height of the moon, go sit under a tree or something, there's going to be a small shade, so you can't avoid shade no matter what. So that's why y can never equal 0 in this graph. All right, next question. This is about the f of x and g of x, f of x, I'm sorry, where you basically solve for g of f of x. Now there's here, the way it's shown up here on my chart is just adding g of x to f of x. So here we have g of x, f of x is just f of x and then adding g of x to that. So g of x is x plus 8. Now, you can do that, but algebraically, there is a second way you can actually solve this. As a matter of fact, that's actually the method I would prefer to use, particularly if you do not have a graph and you're just doing things algebraically. So if we have g of f of x, and let's start with, then what I would do is start here with f of x and just focus on solving that first. So let's do f of x is equal f of 3. So f of 3, that's 3x. 3x, 3 times 3 is 9, and then you get f of x equals 9. fx equals 9. Now, we know that. We can just plug that in where f of x is, and then it becomes g of x, g of f of x. So we know what that is. So we just plug that in where g of f of x, this now becomes f of x, which we now know is 9, and then 9 plus 8 is equal to 17. That's how you would solve this algebraically and how I prefer to do it. But this method here where you just plug in f of x and 8, that works as well. You do whatever makes you comfortable. I'm flexible. For question 3, this is the one where you have 2 points and the goal is try to kind of identify where the line is going to go. So we have 2 points, so all you have to do is plot them here in this chart. See, I have, looks like one, I'm sorry, I could have our graph here, and then after that you just want to identify kind of the direction it's gonna go, and the best way is just to look at it and see, okay, we are going upwards and then we're going to the right afterwards, which means this is going to be sloping upward and to the right. That's how this problem flows. Just start off by solving, putting your points really on the graph, and then you just look at, kind of eyeball where they're at, and you'll find out the slope it's going. Once again, 3b. This time, it's not really sloped at all, as both coordinates share the same x-axis, so it's not really sloped at all. It just stays moving upward and downward, so it just stays vertical in this case. And then 3c, this one is sloped yet again. We go up and then we go to the right. So for the last one, you just go up to the right, upwards to the right. That's just the key. Just know how to graph. If you know how to plot points, sorry for that. If you know how to plot points on a Cartesian plane, coordinate plane, you'll have this pat down, squat. You'll have this good. Now for question 4, you have 3 different graphs. Y is equivalent to x squared. Y is equivalent to x squared plus 7. And then y is equivalent to x squared minus 7. Your goal is to graph this and then compare the 3 graphs, kind of see how they relate and whatnot. And, well, now the best way to do it is just plug in the formula, give it an x value, and just fill out your formula. So, for example, if x is 2, then x squared is 4. That's y. 3 squared is 9. 4 squared is 16, so on and so forth. With that in mind, you plot your points, and before you know it, you have a graph. Now, just repeat this process with plus 7 and minus 7, and you'll get some interesting results. And as you can see on the graph, they're familiar. The most important difference is that they are shifted in a certain direction. When you add 7 to x squared in the equation, your final graph goes up 7 because your y value will increase 7 because you're adding that. So like with 5 squared here, it's normally 25. But since we are adding 7 to it, it's now 32. And that shows here because every value that normally would come up in x squared, just 1, squared is 1, that now becomes 8. Or likewise with 4, 16, it becomes 23 and plus 7, and 9 and minus 7. And that's really the key difference. One graph, the x squared is the kind of the origin, if you want to think of it like that. And then from there, it shifts upwards or downwards, like plus 7 shifts it upwards, shifts all the y coordinates up, and increases the x values. And it'll repeat likewise when you go down for x, when you take away 7. So that's really the main thing I want you all to look at here with that. Question 5, for the 5th question, the key is looking for the reciprocal. The key here is you've been given a equation of a line, and then you will have a point. That point is where you're going to want the second equation that you come up with to look for. And now the key here is to look for the reciprocal of the slope. In this case, blue coordinate is the original coordinate that we started off with, the reciprocal of that is -3/4 becomes 4/3 when you do the reciprocal. And then you use the point slope formula to solve to get your points. So, and afterwards you get y is equivalent to 4/3 x minus 9. And that's pretty much how you do it. If you want me to go through and show you the point slope formula, I would be glad to take some time on that, but I gotta get moving. All right, likewise again, it's the same process here, except first you just want to convert 2y plus 5x minus 9. You just want to make that your point in the point slope format. So if we isolate the this becomes 2y is equivalent to -5x plus 9, and then you just divide both sides by 2 to get y by itself, and that becomes y is equivalent to -5/2 x minus 9/2. From there, you have your slope formula, and you just, once again, pull in the slope formula format, put in the slope formula format, and do the work. It's pretty easy once you get the hang of it. And you can see, look at the lines, and you can see how they're perpendicular because when the line intersects, they have a 90-degree angle between each point. So if they don't line up exactly like this, and your final answer for the second equation doesn't hit the point specified, see this line, 90 degrees here at the intersecting angle, and hits 0,3, requested line, that's when you know you have the answer. So look for that, and you'll be good to go. Now, excuse me, final question. This is the one about the tangent and the line, and tangent lines in a circle. Basically what that means is a tangent line is one that just touches the tips of a circle but never crosses it. So all you're really looking for is a line that touches the radius of a circle but never actually crosses into that. So with a circle centered here, the origin, and your radius of 9, so it extends to the 9-point mark, 9-unit mark across all 4 parts of the axes. So we'll just put our tangent lines here at the specified points, and bam, we have identified the tangent lines. The only noteworthy difference is where they're at in the line. Like the one for 0, 9, that of course is going to go to y equals 9 because we need to get to that point in the positive half of the y-axis. Likewise, at -9, we need to go down to the negative side to intersect it. But other than that, the concept's kind of the same. You're just looking to touch the circle but not get into it. And with all that being said, that is the end of my helping this tutorial today for y'all. I'm so thankful for y'all coming through, and love that you guys are willing to walk with me as we try to solve this together. So I just want to say thank you so much. I can't wait to see y'all again real soon.